Reactions take various amounts of time to occur. These can depend on factors such as temperature of the solution and the environment around it, concentration or the amount of solute or particles in the solution itself, the presence of a catalyst which would speed up the reaction without joining it, and other variables. With this in mind, we also need to be able to determine when reactions can be considered complete before we can identify the time they take. This occurs when the reactants and products reach equilibrium and are no longer moving back and forth from one side of the reaction to the other. However, reactants are available in different amounts in different situations, and each reactant is needed in a different quantity. Think of it this way. In your kitchen, you likely do not have 2 boxes of each type of food present. You may have 3 boxes of cereal, 1 gallon of milk, 2 packages of bacon, and 5 oranges. Then, when you make breakfast in the morning, you also likely use different amounts of each of these items rather than using 1 cup of each ingredient. Chemical reactions work similarly. In a certain situation, more of one compound may be available than another, and certain elements or compounds may be used more often than those around them. So how do we know when the reaction is actually over? One way to know the reaction will no longer occur in a certain direction is if a single reactant is completely used up. This reactant is called the limiting reagent. When this happens, the products made from the limiting reagent can no longer be created, so the reaction is over. Take a moment to pause the video and add this information to your chapter notes. While this may look confusing to determine with chemical reactions, it can be more easily understood with everyday situations. Let's begin with s'mores. In the hypothetical reaction for a s'more, 3 pieces of chocolate, 1 marshmallow, and 2 squares of graham cracker are capable of producing 1 s'more. These students packed the ingredients for their camping trip, but they did not plan ahead. If they brought 12 pieces of chocolate, 7 marshmallows, and 10 squares of graham crackers, how many completed s'mores are they capable of making? An easy way to determine this is to determine how many s'mores they could make using all of each ingredient if the others were not limited. If all 12 pieces of chocolate were used and the other ingredients were not limited, we could divide by 3 pieces per s'more and see that they have enough to make 4 s'mores. If all 7 marshmallows were used with the unlimited rule, they could make 7 s'mores of 1 marshmallow each. Finally, with the 10 squares of graham crackers, dividing that by 2 squares for each, they could make 5 s'mores. So, what was the smallest amount of s'mores that could be made? Looking at our numbers, we can see that the answer is 4 s'mores. Now think about it this way. Which ingredient was limited to making the minimum number of s'mores? The answer is chocolate, because with 12 pieces of chocolate, we determined that you could make 4 s'mores, which is the lowest value we found. So, all the chocolate will run out at this number and no more completed s'mores can be made. This means that in this example, chocolate is the limiting reagent because it is the ingredient or reactant that limits the amount of s'mores that can be created as products. Next, let's think about a recipe for Michael's birthday cake. His dad's recipe calls for 1 cake mix, 1 cup of water, 3 eggs, and 6 tablespoons of butter. He wants to make as many cakes as possible so all his family can enjoy some and take leftovers home. If he has 5 cake mixes, an unlimited water supply, 10 eggs, and 25 tablespoons of butter, how many cakes can he make if he follows the recipe accurately? Let's review this one the same way. With 5 cake mixes and unlimited other ingredients, Michael could make 5 cakes because they only use 1 mix per cake. Since he does not have a limit of water, We can skip this calculation because we know that it will not limit his amount of cakes if it never runs out. Using all 10 eggs and unlimited other ingredients, we divide by 3 eggs and see that he could make 3 complete cakes with 1 egg left over, which will not count toward a whole because it cannot make a completed cake on its own. Finally, with 25 tablespoons of butter following the same rules, he could bake 4 complete cakes. So, which ingredient in this recipe limits the amount of cakes he could make? In other words, which one allows the least cakes with his current supply? We saw that the eggs available made the least amount of cakes if all other ingredients were unlimited, so that means that eggs are the limiting reagent. In other words, eggs are the reactant that would run out and stop the reaction from occurring the soonest. So, after 3 cakes, the product of a full cake can no longer be created. One more practice question of this style. Aisha went to the local sandwich shop to purchase lunch for her friends. She wants to order as many of the specials as possible because she does not know how hungry her friends are. The menu board says that the special consists of 1 6-inch bun, 8 shrimp, 1 cup of shredded lettuce, 3 slices of tomato, 2 teaspoons of garlic, and 4 spoonfuls of their special sauce. However, the cook said that they have been very busy, and while she has plenty of lettuce, tomatoes, and garlic left for sandwiches, she has used up most of her freshly baked bread, shrimp, and special sauce. If the sandwich shop has 12 buns, 45 shrimp, and 26 spoonfuls of sauce left, how many sandwiches can Aisha bring to her friends? Let's calculate this one the same way as the others. Since there's excess lettuce, tomatoes, and garlic, we do not need to worry about those values because they will not limit our reaction by being the first to run out. If we have 12 of the 6-inch buns and imagine that all other ingredients have no limit, we could make 12 sandwiches since each sandwich requires 1 bun. With 45 shrimp and unlimited other ingredients, we can divide the value by 8 shrimp per sandwich and see that with our value of 5.625, we have enough for 5 full sandwiches and a fraction of a sandwich left over. Finally, the 26 spoonfuls of special sauce, when divided by 4 spoonfuls each, can make 6 complete sandwiches, and that leaves us with 2 spoonfuls left over. Which ingredient reached this limit first without being able to finish another sandwich? Well, since lettuce, tomatoes, and garlic were in excess, it was not those. For the buns, we made 12 sandwiches easily, so it was not those. However, we only had enough shrimp for 5 sandwiches, and we had enough special sauce for 6 sandwiches. This means, since shrimp made the least amount of complete sandwiches before running out of supply, it is our limiting reagent. This is because it only made 5 sandwiches total. Now that we have done practice with everyday items, let's apply these new skills to chemistry. The process is very similar. Step 1. As we have done in class, we have to balance the equation so that there are equal numbers of atoms for each element on both sides of the arrow. For step 2, we are going to convert everything to moles. This part is slightly different than the recipes because they all must be in the same unit, but the ingredients in the recipes did not all have to be in terms of tablespoons to make them work. We convert to moles by using the atomic weights in the mass in grams as we practiced in class. If you need a refresher, pause here to see a quick review of the work. In step 3, we calculate the mole ratios. This compares the amount of what we have in the actual ratio to the amount of what we need in the stoichiometric ratio in order to complete the reaction. First, we will use the mole values we just calculated to find our actual ratio of aluminum to chlorine. It is usually easier to put the larger value on top so you get an improper fraction. When we divide the top by the bottom, we get 1.74, which means we have 1.74 moles of the top, aluminum, for each 1 mole of the bottom, the chlorine. Then you calculate the ratio given from the balanced equation by using the coefficients and divide it out the same way. This is called the stoichiometric ratio. Finally, you compare the two ratios. For the actual ratio, we used 1.74 moles of aluminum for every 1 mole of chlorine. In the stoichiometric ratio, we used 0.67 moles of aluminum for every 1 mole of chlorine. Since the actual ratio is greater than our stoichiometric ratio, this means that we have more aluminum than we need to react with chlorine each time the reaction occurs. This means that chlorine is the limiting reagent. If we think about this like the recipes, it would be like this. We have 1.74 moles of aluminum in the cupboard, and the recipe needs 0.67 moles of aluminum, so we could make 2 full batches with some aluminum left over. However, we only have 1 mole of chlorine in the cupboard, and the recipe needs 1 mole, so we can only make 1 batch. So, chlorine limits how many we can make because we have a lot of aluminum left over, but cannot make any more product because we are all out of the chlorine ingredient. This means that chlorine is the limiting reagent. In step 4, we will calculate the amount of product created. In previous steps, we found that we can use up all of the chlorine and the associated amount of aluminum to make as much product as possible before running out of our limiting reagent and stopping the reaction. So, to find the total amount of product, we use all the moles of chlorine from step 2 and multiply it by the ratio of product over the ratio of chlorine from our balanced equation in order to cancel out the chlorine and find our moles of product. Finally, we then calculate the product's yield in grams by using the atomic mass of the product's chemical formula multiplied by the moles of product created, which we calculated above, to find our yield of product in grams. And there you have it. Use this time to make sure the steps from the board are also added to your chapter notes. We will practice more of these problems using chemical equations in class tomorrow after a short review quiz.